Is everybody clear on how we got there? Okay, that's pretty much your first two steps. Solve the top two, eliminate. Solve the bottom two, and eliminate the same variable. Now we have these. Okay? What you do then, so step 3, is eliminate with these two. Take your two new equations. Doesn't matter which one you put on top or bottom. Now you have to eliminate another variable. We got to get down to one variable. That's the goal here. So are either one of our y's or z's already the same? No. So you just have to pick one and try to get them to be the same. Let's eliminate the y's. If we're eliminating the y's, what do we have to multiply the top one by? 2. So we need to get these to both be 10. So by the way, at this point, we're back to section 3.2, right? That's what we did in section 3.2. So multiplying the top equation times 2 on both sides would give you 10y minus 2z equals 50. So what do we need to multiply the bottom one by? So 10y plus 40z. And what's 32 times 5? What? So that's getting negative 160. So what do we need to do, add or subtract? Subtract again. Somebody over here, I don't know who said multiply earlier by a negative. You can still do that. If you want to multiply by negative 5 on this step right here, that's fine. Because then you'll be able to add the two equations. I don't care how you want to do that. It doesn't make a lick of difference to me. It seems easier to me to not have to do that, but whichever way works better for you. So 10 minus 10 cancels. Negative 2 minus 40 will be negative 42. Z and 50 minus negative 160 will be 210. And dividing by negative 42, we get what? Negative 5. I believe that's right. Appears as though it is. So, just like in section 2, once you get this first variable from this problem, what do you do? To what? One of these two. Okay. If you went up and plugged it into one of the original ones, you're still going to have two variables and you wouldn't be able to get an answer. So you plug that first value that you find here, in this case z, into either one of your two new equations. Doesn't matter which one. So plug it into the top one there. 5y minus, 5y minus negative 5 equals 25. So what do we get for y? Y equals 4. Now you have two of your values. Now you plug those, both of those, into one of the original equations. Again, it doesn't matter which one of the three, but it needs to be an original. We found negative 5 for z and 4 for y. Yeah. So we have to find our x. So x plus 2 times 4 minus 5 equals 10. So what's x? What? X equals 7. So that's your answer, that ordered triple, 7, 4, negative 5. That's where those three planes there would intersect. Now before you do your homework, one last thing. These can also all be the same plane, just like they could all be the same line. If they were all the same plane, what would your answer be? Where would those intersect? What? Infinite solutions, exactly. So when you are eliminating, if you end up ever getting 0 equals 0, that's infinite. Okay. The other possibility was the three plane or lines are parallel. The three pieces of paper could be parallel as well. They would never intersect. And that would be something like 0 equals 12. If you were to get that, that would mean there is no solution. There's no place where those planes would intersect. So if you get one of those two things, clear up here in one of these first steps when you're solving, if you were to get that right there, you would know the answer to the problem. Okay, there's no need to carry on if you've got that first step. However, if you were to get 0 equals 10 here, double check. Don't just, okay, that's no solution, move on. Make sure that's what you should have gotten here before you move on. Okay, that's my caution on that. So, homework problems. On page 150, 10 through 16 even. Take your time. You got 4 problems. They don't take that long if you make sure you don't make any mistakes as you go.